Everyone, this is Mrs. Lindsay Pereira. Today we're going to talk about a little bit of review, hopefully, in terms of midpoint and distance formulas, and then we're going to get into how that applies to geometric figures. Okay, and again, these notes are from your student journal, so if you don't have that, please get that out, and then you can resume the video once you get that out. All right, so midpoint. What is a midpoint? The definition of a midpoint of a segment is the point that divides a segment into two congruent segments. So here's an example of that. So if I have a segment AB and M is the midpoint of it, if I know that, then I know it divides the left side and the right side equally. Again, these little markings on here mean that they are congruent to each other. Okay, therefore they're going to have the same length. So if AM is 3, we automatically know MB is also 3. That's what a midpoint means. Now, a segment bisector, the book uses the word segment often, but you won't always see this word. You could just simply say CD bisects AB, for example. Okay, because it doesn't have to be a segment. It can be a line, it could be a ray. So you'll see that this used frequently as well, but also the book will use segment bisector. It's really the same sort of idea as midpoint, but it's not a point. It's always, again, like I said, maybe a ray or a line or something like that. So again, it divides the segment into two congruent parts. So in this case, AM, the left side of the segment, and the right side of the segment, MB, would then be congruent to each other. Okay? So in this diagram, you could actually say a couple different things. You could say line CD bisects AB, or you could also say M is the midpoint of AB. Okay? So again, midpoint is just very much more specific because it's talking about the midpoint. And notice this line CD has to go through the midpoint. Okay? All right, so now this is hopefully a little bit refresher for you. Midpoint formula, use this in algebra, but you will need to know this formula, right? Midpoint averages the x's together and divides by 2, and it averages the y's together and divides by 2. So add them up, divide by 2, add them up, divide by 2. Okay? So again, you can see on here that this line, M is the midpoint, it would divide AM, and MB would then be congruent to each other. Okay? All right. And your other formula, we'll do several examples of these at the end of your notes. But your distance formula, same sort of idea. Given 2 points here, what's the length or the distance between A and B? So here you take your x's and subtract them, square it, plus take your y's, subtract them, and square it. We really get this from the Pythagorean theorem. You actually could just simply do the Pythagorean theorem if you see this forms a right triangle here. We'll do more with Pythagorean theorem a little bit later, but for those of you who are very familiar with it, you could do that as well. This is, again, a formula that you need to know. But let's go ahead and do an example of this in our little note sections here. So if A is -3, -5, and B is 4, -7, find the measure of AB. So in other words, find the distance is what they're asking for there. Okay, that gives you the length of that segment. So what I'm going to do, I'm going to label these as x1, y1, just like I did here. Doesn't matter if I make this x1, y1, or if I make this x2, y2. They just have to match. So if I call this one x1 and this one then has to be y1. I couldn't do x1 and x2. Then this would be x2 and y2. And I'm going to plug that into my formula here. Okay, so AB, the measure of AB, would be the square root, this big long square root. So I'm going to take my x's and subtract them. So I'm going to do 4 minus a -3, and I square it. Then I'm going to do my y's. So y2, so -7 minus a -5. So again, this really turns it into adding here. So it's going to be 7 squared. And again, this is going to be adding as well. So -7 plus 5 would give me -2 squared. Okay, so now the question comes into play. Do these squares and square roots just cancel? Well, that can happen, but only if I had it written as 2 separate square roots. In this case, they would cancel and I would just get 7 plus -2. Okay, well, and actually I have to be a little bit careful with this. This one would be a +2 here. But when it's underneath the entire thing, I actually have to square and add them first. And you're going to see why this turns into a +2 here. So this actually would then become here 49 plus 4. Well, this really turns into 4. The square root of 4 is +2. But again, these are not equivalent to each other. So again, you cannot cancel it like you did over here. So this would be square root of 53. And we would simply just leave our answer like this because this is not a perfect square. And that's completely acceptable. If the directions ask you to round, go ahead and plug that in your calculator. But I'm not worried about that at this point in time. Okay, so you can just leave it as square root of 53. All right, so let's try a few more examples here. Going back to a segment bisector. Okay, so we want to identify the segment bisector, then find the length or whatever the distance is of AB here. Okay, so in our first one, now M is actually what we would call a midpoint. Okay, segment bisector is usually more like a line or a ray or something to that effect. But so in this case, we would say M. M is our midpoint. Okay, let me rewrite that. Just say M is our midpoint, so we identified it. Now we're finding what is AB. Well, since that's the midpoint, we know again it divides it equally. So this portion would also have to be 13. So our whole distance there from A to B would be 13 plus 13. So hopefully you see that as 26. So this would be our answers for both of those. Okay. So number 2. With number 2, we have MC is going to be our bisector here. And again, we know that. We can't just assume it. The only reason we know this is because we have these congruent symbols here. Same thing with number 1, same thing with number 3. If we don't have these symbols, we don't know if we have any bisector or midpoint at all. But in this case, we have ray MC is our bisector. And again, since this portion is 8, this is congruent to it. It's bisected, right? So that has to be 8. So the whole distance there is adding those together. So we get that to be 16. Okay. All right, I'd like you to pause the video. I want you to try number 3 on your own. And when you're ready to check your answer, please push play. Okay, so here we have line L as our bisector. And then again, since we have our markings, our congruent markings here, we know this is also 26. 26 plus 26 would give us 52 for AB. Okay, let's move down here to number 4. Again, identify the bisector. Now we're looking for EF after we do that. So in our first one here, again, because we have our markings here, we know these are congruent. So that means ray MT is our bisector. So we identified it first. Now we're going to find EF. Okay, now EF is the whole segment. These aren't numbers, these are expressions, but we know these are congruent to each other. So congruent also means equal. So we know that 6x has to equal 2x plus 4. So we always take our diagram and we pull off the algebraic equation off of that. Now we have a nice little equation that we are familiar with solving. We subtract over 2x. So we get 4x equals 4. Divide both of those by 4. So then we get x equals 1. Okay, just because we found x, is that our answer? Well, let's go back. We are looking for EF. So here's one thing that you have to do a lot more than what you do with algebra. You typically have to keep going. You got to answer the question. So 1 is not our answer here. We need to plug it back in so then we can find what is EM, what is MF, and then we can actually solve it from there. So if I plug 1 back in here, 6 times 1, that'll give me 6 here. And if I plug it in, it should be 6 because these are congruent to each other, right? So 2 times 1, I'll go ahead and do it here, plus 4, because again, I'm plugging in this 1. Yes, that'll absolutely give me 6. If I got an answer that was not the same, I've done something incorrect in my work here, okay? So now we see both of those are 6, so EF, the entire thing, will be 6 plus 6, which is 12. So we have our bisector, and then we have EF. Okay? So let me put a line here just to separate these guys. Okay. All right, so let's talk about 5. So let's identify the bisector. So again, we have a congruent symbol, so line N is going to be our bisector. That's our first portion of the answer. Now EF. So again, congruent, so that means I can set these two things equal to each other. And now I can solve. I'm going to subtract an x. So I get 15 equals 6x minus 2. I'm going to, excuse me, add a 2. And I apologize, that's a 3 that did not. Right up here, 7x minus 3. Can't read my own handwriting there, so it helps to write it a little bit more clear. So now I'm going to add 3 to both sides. So 18 equals 6x, and then I divide by 6. So x equals 3. Okay, again, do I need to plug it back in? And the answer is probably yes. Okay, yes I do. EF is this whole thing. So if I plug 3 back in, so you can use your calculator if that's helpful for you. I can just simply, let me move this over so you guys can see my screen here. I can simply do, okay, so I'm doing this one, so it's going to be 3 plus 15. And that's absolutely fine if you need to use your calculator. If you can do it in your head or just simply write it out, that's okay too. So I got 18 here. This should be 18. Now I strongly suggest also just checking, plug it into your calculator, because if you get a different answer than 18, you've done something incorrectly with your work here. But we get 18 for both of them. Okay, so EF is the entire thing. So 18 plus 18 is going to give me 36. Okay. All right, so just like before, I would like you to pause, try number 6 on your own. When you're ready to check your answer, please push play. Okay, so M is your midpoint. It's okay if you actually wrote bisector, but a point is usually typically written as midpoint instead of bisector. And then we get x to be 4, therefore when you plug it back in, you get EF to be 16. Okay, so this is really dealing with midpoints and bisectors. In terms of our segments, so in a little bit more format of geometry. Now we're going to talk about it in terms of a little bit more. This might be a review from some of your algebra classes, but it is also geometric because you can graph this on the coordinate plane. Okay, so we're going to find the endpoints. We are given the endpoints of P and Q. We're going to find the coordinates of the midpoint. Okay, so again, what is this midpoint formula? Well, midpoint, I'm just going to go ahead and write it here, is add together your x's, divide by 2, and it's an ordered pair, so comma, add together your y's, and divide by 2. So again, I'm going to add together my x's here, so my midpoint will be -4 plus 0, and I'll divide that by 2. So that'll be the first portion of our midpoint. And then I'm going to take my y's, 3 and 5, going to add those together and divide by 2 as well. So again, remember, add in the numerator first. So that'll be -4/2. I'll do my x first, which then gives me -2. I don't divide first, okay? Add, simplify the numerator, then divide. So, sorry that popped up on the screen. Not quite sure why. 3 plus 5 is 8 divided by 2. Now I can do my division and I get that to be 4. So this is the point that divides this segment into 2 congruent parts. Okay? We're going to skip 8 for right now. I would like you to try number 9 on your own, okay, using your midpoint formula, and push play when you're ready to check your answers. Okay, so midpoint in this case is 6, -9. Again, adding your x's, dividing by 2 right here, adding together your y's and dividing by 2. And a couple more here dealing with midpoint, but the wording on this is a little different, so it's always super important to read your directions. And notice how I'm always highlighting things and different things of that nature, okay? This one is different because they give you what the midpoint is. So you have a segment, J, K, midpoint M, all right? They give you J and M. You are finding K. Okay? So we have to think about our formula a little bit differently. So our midpoint formula, again, equals add your x's together, divide by 2. Add your y's together, divide by 2. Well, we only know x1 and y1. We don't know x2 and y2. That's what we're looking for. We're finding k, which is x2, comma y2. They give us, this is our midpoint right here. Okay? Well, we can think of this as 2 separate equations. If I add together my x's, well, I know x1 plus x2 over 2 equals the x coordinate of my midpoint. I'll just call that x. So I know x1 is 7. I don't know x2. But I know this is my midpoint. So that should be 1. Now I have a little equation that I can solve to help me find the x value of k, this guy right here. So if I multiply both sides by 2, it cancels my fraction there. And I get it to be 7 plus x sub 2 equals 2. Now subtract a 7. So x2 equals -5. That is my first value of k for my endpoint. Now I'm just going to repeat it with my y's. So my y's are y1 plus y2 over 2 equals my y value here of my endpoint, right? Or I'm sorry, of my, my midpoint up here, pointing to the wrong one. So I can plug it in. So y1 is 2. We don't know what our second y is, but we do know our midpoint of the y value is -2. And again, I solve that again. Multiply, I just write this a little bit different way. Multiply by 2, multiply by 2. Over here I get -4, but in this case it just simply cancels there. So I'm just left with 2 plus y2. Again, now we're left with a little bit easier equation. Subtract over 2. And that gives me the coordinate of my y value for my endpoint. So a little bit different for sure with this one, okay? We're going to skip this middle one, and we're going to do this last one together. We're going to skip 11, but we'll do 12 together, okay? So again, think about it. This is your x1. This is your midpoint. This is your midpoint here, so it's our x. So I'm going to take this one. I don't know what the second x is, But when I divide it by 2, it equals not negative 9 over 2. Now this one's a little bit easier than our problem over here. Because the denominators are both 2, I can literally just cancel those out. Again, it's not truly canceling, but my numerators have to be equal to each other. So I can kind of just ignore the denominators because it's only because they are the same. If this was a different number than 2, we could not do that. So now subtract over 2, and we get that to be negative 11. So our first value of k, our x value, is negative 11. And now we do the exact same thing with our y1 value and our y. So y1 is 16, plus we don't know the second y, divided by 2 equals 7. Now we have to multiply both sides by 2. Cancels here, which is nice. 16 plus y2 multiply, we get that to be 14. Subtract over 16. So y2 equals negative 2. And then that is our y value for our endpoint here. So again, big difference in directions there. This one, they give you the midpoint. The previous problems said find the midpoint. Okay, so make sure you understand the difference in directions between these two problems as well as these. Okay. All right, so this concludes our notes for section 1-3.